Hello, everyone. I'm meteorologist Sean Sublett, and welcome to Across the Sky, our national Lee Enterprises weather podcast. Lee Enterprises has print and digital operations in 77 locations across the country, including at my home base in Richmond, Virginia. And as always, I'm joined by my meteorologist colleagues from across the country, Matt Hollander in Chicago, Kirsten Lang in Tulsa, and Joe Martucci in Atlantic City. How is everybody doing this week? We're coming up on the 1st of July when we're recording this. I have to imagine it's getting very hot in Tulsa. Kirsten, how is it going there?
You know, we had a little break and last week was really nice. That strong cold front came down and it felt almost like spring or fall. It was really nice. And now, forecasting out, we have triple digits back. I mean, it's the summer, so it's to be expected, but it was a nice break. I did enjoy it.
Well, Matt, how's it going up there in Chicago?
Oh, I'm loving summer in Chicago because we get these things called cold fronts still in the summer, which doesn't happen in Texas. Up here in the Midwest, every few days, at least recently, it starts to get a little bit warmer and more humid, and then a cold front comes in, and then we get just some fantastic weather. I see why everybody lives in Chicago now, because the summers here are really nice. And it's a good payoff after the brutal winters, which they are brutal.
Joe, how are things at the Jersey Shore, bud?
Hey, Jersey Shore is always a great time. We're getting into the swing of things. We got 4th of July weekend that's passed. Actually, I did a little bit of research. It turns out that this June was our least humid June since 2016 over at Atlantic City International Airport. And there's another city called Millville, home of Mike Trout. That was the least humid since 2006. So actually, if you don't like the frizz factor, you have been very happy.
That, it hasn't been especially muggy for a long time here in Central Virginia. We're going into a legit hot and humid period here into the 1st of July, and that's going to stick around for a while. But I will talk with you, as they say, offline about that humidity stuff. But we'll get back to that later. Meantime, the humidity, of course, does generate thunderstorms, and we are in thunderstorm season, and we've been in it for a while. From Florida to the upper Midwest, we get the thunderstorms. With that in mind, we want to bring in our guest this week, Chris Vagasky. Chris is a meteorologist and lightning applications manager at Vaisala, which is one of the leading weather instrumentation and manufacturers worldwide. And they're known throughout the weather industry for their lightning detection and hardware network. Chris has been with Vaisala for almost 8 years. Before that, he was at the National Weather Center in Norman, Oklahoma, and on the air in Oklahoma City. And Chris has got his BS in meteorology from Mississippi State and an MS in applied meteorology from there as well. Additional coursework done whilst at the University of Oklahoma. And if I ever have a lightning question, the first place I'm going is Chris. So Chris, thanks for joining us on the podcast.
And thanks for inviting me. It's always a pleasure to get to talk to some other weather nerds about probably one of the coolest weather phenomenon that's out there.
It is. It is. Talk a little bit about how you got to this spot. I mean, has lightning always been like a weather thing for you? Were there other things that you got excited about regarding weather earlier in your career and then led you to lightning? So how'd you get to where you are now?
This is the case for a lot of meteorologists out there. This is the case for a lot of kids out there. Lightning used to just scare the pants off me. I was, growing up in Michigan, just a little bit north of Detroit, and thunderstorms would roll in and I'd be terrified. But that got an interest going in weather and in meteorology. So, from the time I was 5 or 6, I started reading about the weather, started meeting the local meteorologists in the Detroit area, and that kind of got me on my path into meteorology, where I then headed down to Oklahoma, which is always in the top 5 for lightning around the United States, whether you're talking about the total number of lightning detections or the total lightning per square mile. So I went from being terrified of it to being kind of in the lightning hotspot, one of them. And then after school, looking for a job, and came across this company with the funny name, Vaisala. In the US, we say, welcome to Vaisala. In Finland, where they're from, they say, welcome to Vaisala. So they swapped the W's and the V's there. But Vaisala, we've been detecting lightning for almost 40 years now, and getting to play with that data day in, day out really drove me even further down the lightning path. So starting out terrified of lightning, now I help people really understand lightning and stay safe from it.
That's really important in this day and age. So we're going to go around the horn as we're, because I know we all have a lot of questions. I think here as meteorologists, we know the basic fundamentals of lightning. It's an electrical discharge in the atmosphere. It gets hotter than the surface of the sun. We know that your tires and your tennis shoes are not going to protect you from lightning. These are things that I think most of us in the weather enterprise know at a very fundamental level. One of the first things I want to ask you, being deep in this, is are there one or two messages that are still out there about lightning that you hear folks in the weather enterprise who do regular weather communications? They're like, oh, that's not really how it is. We need to be more careful. I mean, what kind of things have we learned, if anything, last 5 or 10 years that aren't being told enough about lightning?
That's a great question. And you hit one of the things that, I see repeated a lot, which is my tires protected me, my tennis shoes protected me. We heard that a couple of months ago when a couple of people were struck by lightning in Florida after they left the Yankees spring training game. They said, if we weren't wearing our tennis shoes, we would have died. No, that's not true. Lightning, as you said, it's hotter than the surface of the sun, 50,000 degrees Fahrenheit or hotter. It has more electricity running through it than runs through your walls. So the electricity that charges your cell phone is about 15 amps. Lightning is 2,000 to 20,000 times more powerful than that. A half inch of rubber on your shoes is not going to protect you from that. So let's bust that myth right now. It's not what you wear. It's not what you're holding. You could be holding a golf club. You could be holding an umbrella. You could be holding a cell phone. That's not going to attract you to lightning. That's not going to keep the lightning away from you. So really the big thing, and I'm glad that we've been seeing this a lot from the media, is the lightning safety messages. And we just came out of Lightning Safety Awareness Week. The lightning fatalities in the U.S. have been coming down substantially. We're now averaging around 17 a year in the last few years, down from 50 to 55 a year just at the beginning of 2000. So when thunder roars, go indoors. When you see a flash, dash inside. Those are the messages we need to keep relaying. Then the other thing I'll talk about, you hear and you'll see the number of strikes. Well, strike is kind of a generic term. It doesn't really mean a whole lot in the lightning science. So when you look outside and you see lightning flickering, that whole flickering process is what we call a flash. So when you see the lightning flickering, it's a lightning flash. And that is made up of lightning strokes. Those are the individual lightning channels that are what we detect and what we see as the lightning coming down out of the sky. And a lightning flash can be made up of 1 to 20 to sometimes 40 strokes. And they will strike sometimes all in the same place, but sometimes in different places. So, when we talk about lightning and what it is, you have flashes, strokes, and strikes. And those are the three kind of key things of lightning when you're looking at it outside.
Is that necessarily defined as cloud to cloud or in cloud, or can a flash still be cloud to ground?
Yes, there's in cloud flashes and there's cloud to ground flashes. So the cloud to ground flashes are composed of those cloud to ground strokes that you see coming from the cloud and coming into contact with the ground, a tree, a building, a radio antenna, things like that.
Given the time of year, this is coming out right around the 4th of July. I know you shared something on Twitter when I was doing a little research on you that showed a pretty big spike in the number of Western wildfires due to fireworks on the 4th of July. which are due to a human source. I know it's not particularly related to lightning per se, but you look at this chart here that I'm looking at, and you look around the 4th of July, there might be, 30 or so fires just started by lightning between 1992 to 2015. But then the number of fires started by a human source on the 4th of July is north of about maybe 1,100. I just want to know if you could talk about that a little bit and how that relates to lightning, and when is lightning most likely to start wildfires during the year in the West, which we always have to talk about.
Yeah, that's a great question. We've had some fires started here just recently in Colorado because of lightning. Now, humans cause about 80 to 85% of the wildfires in the United States every year. Lightning is that other 15%. But lightning triggered wildfires burn 60% of the acreage that burns. So when lightning does cause a wildfire, it's usually a big problem. If a human causes a wildfire, a human had to be there. So it's usually easier to get fire crews out to put the fire out. Most of the lightning triggered wildfires are in the Western United States, in Alaska, in the mountainous regions, in remote locations. So they tend to burn a whole lot more. So, coming up on the 4th of July, we've got all the fireworks that are going off and huge drought here in the West. So we're definitely really concerned about human caused fires, but it is also the peak of lightning season. And in a very dry environment, we're concerned about any dry thunderstorms or any lightning in general that could strike some dry brush, dry tree trunk, grass, or anything like that and cause some of those fires. Now, there's kind of special lightning out there that causes more fires than other lightning. And, we were talking about that lightning flash, and you see that lightning flickering. Sometimes some of those lightning flickers last longer than other lightning flickers. So those longer lasting ones are what we call continuing current lightning. Those last for 40 milliseconds to about 200 milliseconds. It doesn't sound like a long time, but it's actually hundreds of times longer than your normal lightning stroke, which lasts for a few microseconds to 10 to 20 microseconds. And so in that longer duration that the lightning's in contact with the ground, it's transferring all of this heat and all of this electricity from the cloud to the ground, and it's much more likely to cause a fire to start. So to be able to identify that, which we're becoming more and more able to do that, especially with the National Lightning Detection Network, we're able to help meteorologists, wildland managers, and others out there to really pinpoint where the most damaging lightning could be so that they can get crews out to do investigations before the fires get too large or before you have substantial damage.
Yeah, Chris, following up on that lightning that lasts longer, that's real interesting to know that's responsible for most of the wildfires. But I'm also curious, is that also what is responsible for more of the lightning deaths? And I think if we could just kind of chat about lightning fatalities. What is the big cause for lightning deaths? What is the main trigger there? Is it the actual lightning itself, or is it a particular activity that people are doing? What leads to the greatest number of lightning deaths?
The Lightning Safety Council and others that are working with respect to lightning safety, we're trying to dig more into what are the causal relationships, and is one type of lightning worse than the other necessarily. The key message that we want to get across with respect to that is that all lightning is going to be dangerous. So anytime there's lightning in the area, you do want to be inside, away from that lightning. Almost all of the lightning fatalities that happen here in the United States happen to people who are outside. On the National Lightning Safety Council website, lightningsafetycouncil.org, we have all of the documentation for activities that people are involved in, the day of the week, the states, how old they were, and all the information you could want on that. The biggest contributors for activities are boating, fishing, and being at the beach. People like to joke about the golfers always being out there and being struck. And while that is in the top 12, being at the water or on the water is really kind of the most dangerous, because you're usually very isolated at that point, the tallest object, and lightning will tend to strike isolated, tall, and pointy objects. So, a human kind of fits that when they're standing on a boat or standing at the beach.
So I have a question that a lot of people ask me all the time when it comes to lightning too. And the question is, the rule that you were taught when you were little about seeing a lightning strike and then counting the number of seconds, does that actually apply? Or is that just kind of something that your teachers tell you, just for fun?
There is definitely a difference in the speed of light and the speed of sound. So the speed of light is so much faster than the speed of sound. So when you do see lightning, you see the lightning flash, you start counting 1, 1,000, 2, 1,000, 3, 1,000. For every 5 seconds it takes for the thunder to arrive, that lightning is a mile away. So if it takes 10 seconds, it's 2 miles away. 15 seconds, 3 miles. Now you can only usually hear lightning for about, hear thunder for about 10 to 12 miles away. So, that can be up to a minute between the time you see the lightning to the time you hear the thunder. But lightning can also strike 10 to 15 miles away from the storm. So anytime you can hear thunder, you are close enough to being struck by lightning.
I think that's a really good point. And I think it's a point that most people really aren't cognizant of when we think about, and I know the weather folks among us understand this, but I think it's worth you bringing forward, Chris, is that how far away lightning will strike away from a storm. Could you speak to that? Sometimes you hear about these quote unquote bolts from the blue, or a strike from the anvil, or a positive strike compared to a negative strike. Can you speak to those points real quick?
Bolts from the blue or anvil strikes, it tends to be, the weather is dry, the sun may still be shining, and thunderstorms off in the distance. Most lightning in a thunderstorm occurs in the core of the storm, but about 10% of it occurs outside that core of the storm. And it can strike 10 to 15 miles, sometimes even longer, but the further you get away from the storm, the less likely it is. So that's why we always like to remind people, anytime you can hear thunder, you are close enough to be struck, because actually most people who are struck by lightning are struck as the storm is approaching or as the storm is leaving. Because when the storm is overhead, it's raining and people have gone inside to get dry. But dry doesn't mean safe. You still have lightning that's approaching or that's leaving, and it can still extend out and strike you even if it's not raining.
Yeah. So unlike the Fleetwood Mac song, thunder doesn't always happen when it's raining. Oftentimes it happens way before that. Okay, we're going to take a quick little break, and we'll bring back a few more questions for our guest, Chris Vagasky at Vaisala Applications, all about lightning detection, safety, and the like. So we'll be right back on the Across the Sky podcast. And welcome back, everyone, to the Across the Sky podcast. We're here with Chris Vagasky, Vaisala Lightning Applications. Or actually, that's not like, you do a lot of stuff there, okay? But lightning is what you are known for in this line of work before anything else. So another thing about the impacts of lightning on people that I've wanted to ask you for a while. Sometimes I hear stories about what happens to the body or what the body might feel in the last few moments before a lightning strike. I've heard people report that they felt tingly. I had a friend of mine who was literally playing golf who let go of his golf club, fearing that he was going to be struck by lightning because he started to feel warm. Are there any oh my heavens, I have 2 seconds before I'm going to get struck, clues that you might get from your environment? Or is this all just a bunch of stories?
No, it's definitely not stories. And I've seen recently some people in Colorado who were on a hike, and they were up on a 10,000, 12,000 foot ridge here, hair standing up on end. There's a real famous picture from back in the 1970s of a couple of people whose hair was standing up on end. I have a friend who's a PhD meteorologist out of the University of Oklahoma. He's been kind of traveling the national parks in the West here the last couple of weeks. they were out in Death Valley, and believe it or not, Death Valley does get lightning, and there were storms in the area, and his dad was pointing, and there was a buzzing coming from his finger. So there are cues out there that the electric field is really strong, and you need to get into a lightning safe place. So if you do start to hear a buzzing sound, if you do feel your hair start standing up on end, if you do start to see the clouds building, maybe it's time to end that outdoor activity that you're working on and get inside.
Is there any way to know how many seconds you have? Like, I'm outside, I'm wrapping things up, I'm starting to feel tingly. I mean, do I have a second? Do I have 5 seconds? Do I have 15 seconds? Is there any way to know? I mean, obviously, if I had that feeling, I want to get my butt inside pronto. But is there any way to know if you have a few seconds or longer, or is it just good luck, buddy? You're on your own.
Yeah, at that point, it really is good luck. In the lightning science, the science is not at the point where we can predict when and where lightning is going to strike. There are people who will try and tell you, we've got this sensor that will tell you when lightning is going to strike so that you can get in before the lightning happens. Don't believe that. We cannot predict when and where lightning is going to strike. So when you do start to hear the thunder, you start to see the lightning, you see the clouds build up, heaven forbid your hair stands on end, get inside, because you don't know if it's going to be 1 second, 1 minute, and it only takes one strike to cause permanent injury or even kill you.
Hey, Chris, and I'm trying to think back, just following up on this, back at when I used to work in consulting weather, we did do what we would call lightning heads ups for clients, let them know that lightning was possible. Isn't there something to looking at a radar and seeing what the reflectivity strength is at certain heights of the atmosphere? And that will help, not 100%, but at least give you a good idea of when that lightning is coming in. I can't remember the numbers. It's been a couple of years, but there was some kind of formula that we used to use.
Yes, you can look at different things like the reflectivity thresholds at a certain temperature value, usually between -10 and -30 degrees. Or you can look at electric field strengths or other characteristics. In the U.S. Space Force down at Cape Canaveral, they have a really long list of lightning launch criteria that they use to decide whether you can go for launch. And I've been in the room with them as they've been going through all their launch procedures before launching a rocket. And it's fascinating. But these are, again, all guidance, and they're not going to say at 10:22 and 30 seconds at 39.482 degrees north, -106.13 degrees west, there's going to be a lightning strike. The science isn't there yet. We're still trying to figure out exactly why some storms produce as much lightning as they do, or why some storms produce as little lightning as they do, and why it picks certain points. Lightning comes out of the sky at 200,000 miles an hour, so you're not going to avoid it when it decides to strike. So really, if you can see lightning approaching, you hear the thunder, you see a storm approaching, or if you're doing some weather consulting and you're watching a storm approach on radar, as the lightning starts getting closer, and when you get within about 8 to 12 miles, wrap things up and get inside.
Just kind of going back to busting some of those myths that, people have a lot when it comes to lightning. We tell everybody, like we're saying, get inside, whenever this is happening, make sure you're safe. But are there things inside that you should avoid as well during a lightning storm that could potentially be hazardous?
So we always say when thunder roars, go indoors. And when we say go indoors, a lightning safe structure like a house or a building that has electrical and plumbing running through the walls, or a fully enclosed metal vehicle. Now, people do still get injured by lightning when they are inside. And a couple of stories that have happened just in the past year. Last year, there was a woman that was working from home in Oklahoma City. Lightning struck the roof of her house. The electricity traveled through the wiring in her house and came in through her computer, and she was holding her mouse, and she was injured by the lightning coming through the wiring and actually coming through the mouse. there was also a story last year in Tennessee of a guy playing video games, and he had a wired controller. The lightning struck nearby, in through the wires, in through the video game console, into the controller, and he was shocked. So when you are inside, away from the lightning, don't be touching things that are plugged into the walls, and don't be touching plumbing fixtures either. So don't do the dishes, don't take a shower, and use only cordless items.
I think that's great bringing up you're still a little bit of a threat, not nearly as bad as being outside, but the fact that there are certain things you should avoid doing during a thunderstorm, because I think that's what a lot of folks will end up doing. Oh, it's like, oh, well, I can't be outside right now. There's a thunderstorm, so I'll just get on my laptop for a little bit. But that's actually not a good idea. You should actually probably avoid being on electronics, and maybe just take a good digital break. Might not be a bad idea. I guess your phone's okay, but anything that's plugged into the wall would be the thing to avoid.
Correct. Yeah. As long as it's unplugged from the wall, you're okay.
And Chris, I wanted to get your opinion on something that's kind of a hot button issue in meteorology, something that's been up for debate. And I think something that maybe the public doesn't know when it comes to severe thunderstorm warnings. You know, we issue severe thunderstorm warnings for the wind, for the hail, and if it's producing a tornado, then it's a tornado warning. But a severe thunderstorm warning is for 60-mile-per-hour winds and quarter-size hail. But one of the things that's come up is that maybe they should issue severe thunderstorm warnings for the lightning. Now, every storm can produce lightning, but we do see certain storms that produce more lightning than others. Some storms are just real intense, and maybe they don't have the quarter-size hail, and maybe they don't have the 60-mile-per-hour winds, but they are just producing a tremendous amount of lightning and some very heavy rain. So I'm curious to know your opinion. Should we issue severe thunderstorm warnings for storms that are producing a lot of lightning? And if so, what do you think should the threshold be for the amount of lightning that a storm is producing to trigger one of those warnings?
You know, that is a great question. And there's a challenge, because this is some work that I've done. And a couple of years ago, I presented at the AMS meeting. How much is a lot of lightning? A lot is, kind of a generic, it's a nebulous term. A lot means different things to different people. So last week, there was a lot of lightning in Southern California. And when I say a lot, there were 66,000 detections over about a 24-hour period from the National Lightning Detection Network. And that ranked in the top 2% or even the top 1% of storms in California. But that doesn't really register to somebody in Florida, where you get 15 million lightning detections every year. So, it's a challenge to go through and be able to say, we need to issue a warning because there's a lot of lightning with this storm. I've seen the Weather Service putting out special weather statements for storms that are producing, in their minds, what is a lot of lightning. And I think that's a good starting point. And Kirsten, I don't know if they do that in Tulsa, but I know in Oklahoma City, whenever we had a significant weather advisory issued for a thunderstorm, we put up the bug on the screen to say, there's a strong thunderstorm. But Oklahoma City is a little different animal when it comes to weather on the air. But really, the key takeaway message continues to be, anytime there's lightning around, don't put yourself into harm's way. And we've been doing such a great job with that. Last year, 2021, we only recorded 11 lightning fatalities in the United States, which is a record low. And this year, we've only had one fatality so far. It was during the California storms, but we went a record length into the year before we had our first lightning fatality. So the message is working.
That's good, because everybody's climatology is different. Everybody's threshold is different. I'm kind of with Matt. I wish there was a way we could quantify that in a warning, but going through the details of that would be just really, really hard, depending on what part of the country that you're in. Now, for the longest time, the only place to get good lightning data is through Vaisala, right? The lightning detection network for years and years and years. But more recently, with the GOES-R series of satellites, there's a lightning mapper. Can you talk a little bit, without getting too deep into the technical specifications, as to how the Vaisala network is different in detecting lightning versus what's being done by satellite now?
Yes, so they are detecting two different things. We're detecting lightning, but it's different methods in which we're doing it. So every time lightning occurs, whether it's in the cloud or between the cloud and the ground, it acts like a giant radio antenna, and it sends radio waves around the world at the speed of light. So the Vaisala National Lightning Detection Network here in the continental United States and our global lightning network, which covers the entire planet, act like antennas that are just listening for these radio waves. And when those radio waves reach our sensors, we record the time that it occurs and the direction that that wave came from. And using multiple sensors that recorded the same wave, we then pinpoint where that lightning occurred. And based on the shape of the wave, we know how powerful it was, whether it was in cloud or cloud to ground, whether it was positive or negative. Now, the GOES-R series of satellites, so we've got GOES 16, 17, 18 up there now. They have the geostationary lightning mappers that are just looking down at the tops of the clouds 24/7, and they're looking for light from the lightning. And they're taking pictures of that light from that lightning constantly. The GOES-R doesn't know whether that light is coming from in cloud or cloud to ground lightning, but it does kind of give an idea of how widespread that lightning is. So actually earlier this year, the World Meteorological Organization announced 2 new world records related to lightning for the longest distance that it spanned and the longest duration that it occurred. And they used data from the GOES-R satellites and from the ground-based networks to quantify and qualify exactly how long the lightning lasted, how long it spread, how many cloud-to-ground events were associated with that flash, and things like that. So they're complementary kind of technologies.
I don't know if you can even answer this, Chris, but I'm going to ask you because I got you here. For a lot of these phone apps, I know everybody's phone app is different, and there are these lightning detections on phone apps. Do you know when you get a lightning notification on a phone app, if it's cloud to ground or if it's in cloud, or do you even know? It's just there's lightning, go hide.
So the majority of the phone apps will be cloud to ground lightning. If we showed every dot on the map for every lightning detection, it would get kind of overwhelming because we detect 2.5 billion lightning events around the world every year. So in 3 years, we can give everybody on the planet their own lightning event for their birthday. But most of the lightning that you see, if a lot of people use radar scope, the lightning that you see on radar scope is cloud to ground flashes. Some of the other apps, they kind of keep it kind of tucked in the weeds there. Some of it's, in cloud and cloud to ground. Some of it's cloud to ground only. But and then some of it actually comes from a network of kind of hobbyists who have set up their own lightning network. So some of the data can be questionable. So anytime you do see lightning on the app or getting a lightning alert, it's probably a good idea to get inside. But there are sometimes questionable data out there.
So my question here is a little out of this world, no pun intended. Just want to know if you could give us a brief overview of lightning on other planets. Do they happen? How they happen? Is it the same process? And are you guys tracking that?
Yeah, so lightning does happen on other planets. It's been detected in Saturn. It's been detected in Jupiter. We all know the big red spot on Jupiter is this giant storm that's been ongoing for years and years and years. We've been able to see that lightning as satellites have kind of circled these other planets, gone past these other planets. Vaisala isn't involved in satellite detection of lightning, so we only do ground-based detection of lightning, but what we can do with ground-based sensors to detect lightning is incredible. In 2019, we detected lightning 30 miles from the North Pole. That set a Guinness World Record for the furthest north lightning on record. We've done some really cool stuff with lightning. We've got some really, really smart people that I work with who've basically invented most of the principles of lightning detection. And then I use my comparably smaller brain to figure out exactly how to use that data in new and exciting ways.
Going back to what the point you brought up earlier, that a lot of lightning fatalities are associated with water. And I think that might contribute a little bit to somewhat of a myth that water attracts lightning, which isn't true. All it does actually is conduct lightning, conduct electricity, but it doesn't necessarily attract. But when you're the tallest object, when you're just surrounded by a body of water, you could very well be the tallest, skinniest object, and then you're more likely to get struck by lightning. But it's not the water that's attracting the lightning. All water does is, yes, conduct the electricity. But are there any other lightning myths that stand out to you that you really want to? We did the tornado myth episode last week, so we're trying to knock out lightning myths as well. Are there any other lightning myths out there that you really want people to know about and know the facts about?
Yeah, I think we've covered a few so far. So you can't predict lightning. The rubber on your shoes and the rubber tires are not going to protect you from lightning. Holding a metal object or holding a cell phone is not going to attract lightning to you. Lightning does strike the same place twice. The Empire State Building is hit several times a year. The Willis Tower, I keep always wanting to call it the Sears Tower, gets struck probably more than any other building in the United States. Another one, it's not really a myth, but a lot of people don't think they're going to be struck. Lightning, when you think about it, lightning is only about as big around as a golf ball. And in the most lightning prone areas of the world, you get about 200 to 300 lightning events per square kilometer per year. So that would be take 200 to 300 golf balls and randomly place them around a 1 square kilometer area. And a square kilometer is about 18 football fields, something like that. So it's not going to strike a lot of places. So unfortunately, what we see in the lightning safety community is people who say, I'm going to put up a thing on your building that's going to prevent lightning. Well, your building wasn't likely to get struck by lightning to begin with. So they say, I put this up there. We haven't had a lightning strike. It works. And, unfortunately, I see this a lot of times, and I see it really frequently, unfortunately, at baseball stadiums. I went to Coors Field, and I have a reason for bringing up Coors Field. One, it's down the road from me. Two, I went to a game and I saw these lightning prevention systems, which really don't prevent the lightning, on the light stanchions. But, they put that up there and they say, we're going to be protected from lightning. Well, it doesn't work. I've seen, and we've detected lightning at baseball stadiums that have these devices up there. But that leads into another kind of a myth of I'm not going to be struck. And so people take risks because they don't think it's going to happen to them. And, we're seeing this very frequently at baseball games. I published a paper earlier this year that looked at lightning around Major League Baseball regular season games. 1 of every 14 games has lightning that's within 8 miles of the ballpark, which is an unsafe distance, as we've talked about. That happened last night. So June 29th, Dodgers and the Rockies were playing. There were multiple lightning strikes within about 4 miles of the ballpark. They even started clearing the stands because they were seeing the lightning, but they kept the game playing. It's something that we in the lightning safety community are really pushing on, is these large outdoor events and getting people to take the lightning threat seriously. Because, as we say in hurricane season, it only takes one. As we say, in severe weather season, any tornado is going to be the worst tornado of your life. In lightning safety, any lightning strike that hits you is going to be the worst lightning you've ever experienced. Again, anytime you hear thunder or have lightning in the area, get inside, get away from that lightning.
Yeah, I mean, Chris, it's one of those things. I remember when my kids played Little League baseball and there'd be a thunderstorm coming around. We're in this big, flat, open area. And I'm a meteorologist. I'm like, these kids need to get off of the field. And these umpires are just like, well, I'll evaluate it. I'm like, and you have no idea what is going on. And I think that's one of the things that we need to keep reminding people of. as meteorologists, as weather safety, enthusiasts, if you will, because, it's one thing if you want to go off and take some risk, but man, I don't want my 11-year-old kid out on that baseball field when there's a storm coming. He's inside now. In fact, the reality was we took him off the field and they called him out. But I'm like, you know what? I don't care. He's not going to get struck by lightning. So Chris, thanks. Thanks so much for spending some time with us this afternoon. We've been talking with Chris Vagasky of Vaisala, one of the leading lightning detection organizations. They've got the hardware, they've got the network that's been doing this line of work in lightning detection for all of my career, if not even a little bit before that. So Chris, thanks again for joining us today.
Thanks for having me. Really appreciate the opportunity to get to share some really great information about, one of the really cool weather phenomenon that's out there.
It is cool. And, a lot of us like cool weather phenomena, but we also understand sometimes the cool weather phenomena are also very dangerous ones. Chris, thanks again so much for joining us. We're going to have a few parting thoughts when we come back on the Across the Sky podcast. And welcome back to the Across the Sky podcast. We had a fantastic discussion about lightning with Chris Vagasky over at Vaisala. For those who don't know Vaisala, they've been doing lightning detection in our line of work for years. And there's always something new to learn about lightning. So it was really great having Chris with us.
I'm going over all the interesting stuff that we talked about. And one of the things that struck me was how there's certain lightning strikes that cause wildfires more easily, the ones that last longer. And that lightning strikes are responsible for the majority of land that is burned, because they tend to occur in rural areas where the fire crews struggle to get to. So yes, technically people start more wildfires, but they tend to be closer to where the fire crews can get it. So ultimately, lightning strikes are responsible for the most acres burned, even though they start fewer wildfires. And there's a particular type of lightning that lasts longer that tends to cause those fires. So I thought that whole discussion was real interesting. Wasn't the percentage that he threw out 60% of the land that's burned is because of lightning strikes? I believe that was the percentage that was mentioned.
The percentage, I think, was 80 to 85% are caused by humans, but 60% of the land burn is caused by lightning. And I didn't think about it that way, but it makes sense, because if you're a human and you cause the fire, you're more than likely to call the fire, forest fire service and tell them where it is, or they can track you, than just something natural that could strike at any time. And then you kind of have to find it. And, if you're in the West where it's pretty sparsely populated, you might not notice it for a little bit. Yeah, I thought that was interesting. Also, the lightning on other planets. Thought that was always good too.
Yeah, he had a lot of just really great information. It was great talking to him. I'm with you, Sean. You can listen to him for a long time. And I think lightning just really, he said it too. It's just one of weather's great phenomenons, and people are really just intrigued by it just because it's so unique.
It's one of those things that, we're still learning more about it. We know the fundamentals of it. You've got ice, you've got liquid, and, water is a polarized molecule. So you bump it up against, and you develop this electrical field, and boom. And, that the fundamentals of that are pretty well understood. But in terms of the impacts and where it's going to discharge into what location, that stuff is just, it's really, really so hard. And the other thing that I think was very important that he brought up, all these like lightning prevention things, like, oh, we're going to put this thing up and protect the area from lightning. That's all bunk. That's all just bunk. The amps or the current is far, far too high for any of these little things on the ground to impact it. And I think that's very key.
Yeah, things not to waste your money on. You can add that to the list, the lightning prevention stuff. That's good to know. And before we wrap, I want to get your opinions on should lightning be included in severe thunderstorm warnings?
I'll start because I have given this some thought. I would like it conceptually, but I really have no idea how it would truly be incorporated with the idea that a lot of these pulses of lightning, where we'll get to this, you just have this massive discharge. It's 5 minutes and then it's gone. So by the time you warn on it, it's over. There are some exceptions, like with and y'all excuse me, with an MCC, a mesoscale convective complex, where it's very lightning intense for a very long distance. But when that's the case, you're also normally warning for high winds. So I hear what you're saying, and I want to think of a way to do that, but I can't think of a good way to really do that in an objective way that's going to work, regardless of whether it's Florida or Washington State, which are two vastly different climatologies for lightning. So I like that idea, Matt. I really, really do, but I have no idea how we'd implement it.
Yeah, I don't know if you heard him saying how there'll be significant advisories put out for specific storms in Oklahoma City. It happens in Tulsa all the time too. And they just basically say frequent cloud to ground lightning. But yeah, I don't know if this is the right word, but how would you quantify that? How would you actually, but I think it's a great concept. I agree with Sean.
Yeah, Sean pretty much said what I was going to say. So, or conservation and say ditto on that one.
I think that's the problem, is just figuring out, what would be the threshold for how many lightning strikes would be enough to issue a warning. And it is true that I think most severe thunderstorms, tend to have a lot of lightning. So you get, a lot of the storms are covered by severe thunderstorm warnings, but there are some that are producing really heavy rain, a lot of lightning. In the age of social media, a lot of people are talking about it, but technically it's not producing the quarter-size hail. It doesn't have the 60-mile-per-hour wind gusts, so there's no warning on it. Yet it's still highly impactful and definitely a storm that people should be heading indoors for. So there's few storms that are just these really strong storms that aren't quite technically severe. So I think my opinion right now is that we should hold off, stick with the hail, stick with the damaging wind, but hopefully we can start to learn more, like Chris was saying, about why do certain storms produce more lightning than others? If we can get there and understand the science more, and then be able to forecast when we're probably going to see storms that produce more lightning, then maybe we can consider in the future including lightning in the warnings. But until I think we understand the science more and can better predict how prolific a lightning maker a storm is going to be, it's probably something that we should avoid right now. And again, most of the storms are covered, I think, by the current severe thunderstorm warnings.
I suspect you're right. Anything else, everybody, before we wrap up and celebrate the 4th of July?
Happy 4th.
Happy 4th.
And remember, heat safety and lightning safety. I think those are the two big ones for the 4th of July.
Yeah, it's summer everywhere. So just, most people know this. Hydrate, stay in the shade if you can, get in the air conditioner if you can. If you start to get a little woozy in the heat, get out of the heat if you can. Don't overexert. All those things people have been preaching at you ever since you were 9 years old. Just keep them in mind. We don't want to send more people to the hospital because of heat as we go through the summer. All right, so that's it for this week. I appreciate Chris, of course, joining us there from Colorado. And for Matt Hollander in Chicago, Joe Martucci in Atlantic City, Kirsten Lang in Tulsa, Oklahoma, I'm Sean Sublett from the Richmond Times-Dispatch, part of the Lee Enterprises Network. Thanks for joining us. Have a happy and safe 4th of July from all of us at the Across the Sky podcast. We'll see you next week. So unlike the Fleetwood Mac song, thunder doesn't always happen when it's raining.
Michael J. for Hope for the Warriors. Started back in 2006 at Camp Lejeune. Military families witnessing the effects of war on their loved ones. Now, almost 20 years later, they've aided over 53,000 service members, veterans, and families with confidential, high-quality behavioral health care services at little or no cost to post 9/11 vets and their families. Over 91% of every dollar donated goes directly to the programs. If you're as concerned about our heroes as I am, go to hopeforthewarriors.org.